Welcome back. Considerations for using cache. So, in the previous video, we talked about what is cache and why we need it. Right now, we need to talk about some considerations for using cache. So, using caching effectively involves several important considerations to ensure that it improves performance and reliability without introducing new problems. Let's talk about some of them. So as you can see, we have right now our system, we have the server, we have the database, and right now when the cache is handled, it's handled the frequently accessed data to make sure that we serve the client in a faster way. But there are some considerations that we need to put in our head. Let me just make this font different. Yeah. And left. Okay. The first thing that we need to think about, which is the data freshness and consistency. Because like cache invalidation, because we decide how and when to invalidate or update the cache entries to keep data fresh. We can use that in the time to live. Like we should set like an expiration time for a cache, and we should make sure that our expiration time is not too long, so our data will not be stale. And also we should make that it's our time to live is not too short, though we will keep updating the cache over and over and over. So what causes this problem? So let's say that we have a user, and the client will trying to send a read request to read this user. When the client send to read the user, and the server will obtain it, will try to get the user from the database, will make a query for it. The server will save it, the user in the cache. Okay. Right now the user, we have a copy of the user info in the cache, and whenever the client are trying to access the new user, the same user again, the server will get it directly from the cache. But what if other client or the same client send a read request, a write request to edit something in the user, a name or something? The server will update the cache, or the server might not be able to update the cache. So because of that, we need to make sure that we have a time to live. So the user info will not be all time or forever. Otherwise, we will have a stale data. We have maybe a false information about the user. Also, we need to think about consistency model. So we should ensure that the cache and the primary data source remains consistent, choosing between the strong consistency and eventual consistency. And the strong consistency will ensure that data is always up to date, often using synchronous updates. This one takes time. So when the server is updating a user in the database, before we send back a request to the client, we will update it directly to the cache as well. And when the cache updated successfully, we'll send it back to the client. This one, we have a strong consistency, but we will have extra steps, and extra steps mean that we have we have more latency. We improve, we provide more latency, which is not might be good for some applications. Others are fine with that. We could have some eventual consistency, so we accept that there will be a delay before changing in primary data storage, and we try to send the client directly. So what will happen in this example? So instead of the client waiting the cache to make sure that it saved the user successfully, the server will send the request to the client, and maybe we'll send a message queue, and the message queue will update the cache or something like that. Also, we need to think about let me put the second. We need to think about the cache size and eviction policy. So in cache capacity, so we should determine the size of the cache based on the available memory and expected workload. And also we should work on the eviction policy. We should choose a policy for removing all data when the cache is full. There are some common policy for that. We have a least recent used, we have a least frequency used, we have a first in, first out, and we will talk about them in a separated video. We need as well to think about the read and write patterns. So if we have a read heavy system versus if we have a write heavy systems, a read through check, like we can have like a read through check, so data is loaded into the cache on read misses, and this one's suitable for read heavy workloads. We have write through cache, so data is written to both the cache and the primary data source simultaneously, ensures their consistency but can be quite slow. We have write behind or write back cache, and this one data is written to cache first, first and asynchronously written to the primary data source. Improves write performance but requires handling potential data loss scenarios. We have other things to think about for that data access pattern. We have hotspots, and we have cacheable and non-cacheable data. We have cache placement. We have cache security. But I would say that these 3 points, I guess, are the most important points that you will think about more than one time in any system design interview. So I guess it will be good to talk about these 3 points. So in conclusion, effective caching requires the careful considerations of various factors, including data freshness, cache size, access pattern, security, and cost. By adding these considerations, you can implement a caching strategy that significantly improves performance, scalability, and reliability of your application. So that's it for this video, and see you in the future.